Mr. Raffael Marty.
All right. Now that we're over the first hump, I hope everything else is going to go fine. What I'm going to talk about to you in the next hour is something that you might have heard of before, insider threat. It's something that is more and more of a topic in today's environment. What I'm going to try to do is I want to try to show you how you can actually take visualization and do insider threat detection. So before I start, I quickly want to tell you who I am so you know whether you can believe me or not. I work at a company called Splunk, and I actually brought some T-shirts for you. So I still have the kit for the most intelligent question. But for everyone else who asks questions, I have a few shirts here. So ask me anytime during the presentation or in the end, just interrupt me if you have a question, and you get a T-shirt, unless it's like a question I really don't like. I don't like that question. You asked me what my name was. Sorry. Nice try, though. So I work at a company called Splunk, and I just started there a month ago. I worked for ArcSight before that. I will tell you in a second what Splunk is. I will actually show it during my presentation. Before that, I was at ArcSight, which is a SIM, ESM company, does log correlation, log analysis. And this is basically the practical part of what Stefano before was talking about. And he said correlation doesn't work. Well, we could have some very interesting arguments. We probably should have a panel or something. Before that, I did a lot of work. Oh, okay. I'm also active in the community. I'm on the Oval board. And I founded together with Miter a effort to try to standardize event formats. If you're familiar with the space, there's a lot of problems that all these devices, they generate very, very different messages all over. There's no taxonomy. There's no common transport. So we're trying to pick up that problem again and once again try to standardize this, hopefully successful. And as I'm here, I have a certain passion for visualization. And you see that I have a portal that I maintain, secvis.org, which is really something for you guys to share information, to share ideas on how to visualize things and discuss things. Why is visualization not working, or what did you find to be working? All right, so what is the goal of my presentation here? Really, it's pretty simple. I want to detect insiders by using visualization. And the agenda looks as follows. Here we go. Too much animation, I guess. I want to show you a very quick example in the beginning that just shows how visualization could be applied to a real-world case. I didn't fabricate the case. I fabricated the data to support the case, but you will see that in a second. I want to then quickly talk about visualization in general and give you some maybe food for thought of how to apply visualization, show how you can take data and visualize it, so the whole kind of pipeline from getting the data out of a product or a syslog or something and getting it into a graph. And then I want to shift gears and show you or talk about insider threat. A couple of slides about just theory. What is insider threat really? What do I mean by that? And then I want to propose an insider detection process, so something you can go along step by step to detect insiders. If it was always as easy as just looking at the people to know when there is an insider, that would be nice, but unfortunately it's not. So here it's pretty clear that these are bad people. Normally it's not, and there was a case in early 2007. The company DuPont had a scientist, Gary Min, who was working for them, and he started downloading a lot of documents and intellectual property from their internal servers. He had legitimate access to that, but still, someone that downloads 22,000 scientific abstracts and 1,600 or 16,000 documents, I'm not sure if he can ever read that data. So they found that he wanted to sell this data to a competitor of DuPont. It was never caught. There's no evidence that he actually was able to successfully sold them. But still, the loss would have been around 400 million if it actually happened. Now, well, how could this have been prevented? And I guess this is the first question that a good answer gets a shirt. Come on. I know it's 5 o'clock, but still. What do you do? What's the talk about? How do you prevent this? Yes, visualization, t-shirt. What are you? What's your size? Big size. All right, I will have a double XL here for you. If you want to pass that back there. Exactly, or log collection, right? So you collect all the log files around this problem, and you try to find the problem in there. So I generated some data, and if they did some very primitive basic visualization, and here I just really use a bar chart. You can do this in Excel. The only thing I did is I have all the user activity on the y-axis, or the x-axis, and on the y-axis I have how many times or how many documents did this person look at. Very simple, the top bar just sticks out. There's something wrong. Why did this person access so many documents? Well, granted, you can say it's a little fabricated because you would have to, for every possible problem, you have to generate a graph like this. Well, okay, I agree with you. But if documents were one of my crown jewels, I would probably monitor them. And I would probably monitor these kinds of statistics. I could also do it a little more generic. What I could try to do is generate a link graph. A link graph is something that has nodes and edges connecting them, right? So in this case, what I did is I take the originator node as the user, and the other node is the server they access. So I look, for example, at NetFlow data. I look at maybe login data from my Windows event log or from syslog. I can look at any kind of data that I have where I see users accessing servers. So if I visualize this, I will probably end up with something like this, where I have a lot of circles that are the users, I have the rectangles that are the servers, and the connections are who accesses what. I can see a lot of things in here. I don't even want to go into the details, but what I did is I took the size of the circles to be the number of times I saw this user accessing a server. So very, very clearly, there's one node again in here that sticks out, and it's scary. So this is really just kind of a motivation for visualization of security data. So let me ask you a few more questions to get a little bit of a feeling for what you guys are doing. Who's looking at the log files? Oh my God. I count like 8 hands in here. It's a little scary. Who is visualizing those logs? 3 people. I have 3 shirts here, so please get one if you want one. Who's using Afterglow? Oh, you get a very special shirt. I will show you what Afterglow is. Have you heard of secvis.org? A few. Well, now the other ones have heard of it too. Good. Any other tools you use for log analysis? Tenshi! Nice. Well, he's the author of Tenshi. He has to use it, right? All right. So let's step back and very quickly talk about visualization in general. Why would you use visualization? Why do I think it's something useful? Well, if you look at visual representations of data, you will always see things in there that you say, oh, I knew this. That's duh, right? Why do you show this to me? Well, the interesting thing with visualization is also there will be questions that pop up that you didn't know about. You look at your data and you're like, what is this? And you find the answers to them mostly. The other thing is it will increase your efficiency. Think about it. If you look at the log files, 10,000 lines, you have your 10G log, right? You need to make a little advertisement for you. You look at all those log files. Once you hit line number 50, you forgot what was in line number 1. I can guarantee you that. And if you end up at 10,000, you forgot what all the rest was. So with visualization, you have everything at one glance. You look at it, a certain property of your log file, and you can look at it in one picture and analyze it. It's also a great tool for communication. There's actually a gentleman here in the audience, I think, and his company used to send out emails from the security team to the operations team saying, hey, here's a problem with your machine, here's the log file, please remediate the problem. And they got the log back, the operations people were saying, what are you talking about? We have no idea what this means. So they started sending them graphs, saying, look, your machine connects to all these others. Apparently there's something wrong with your machine, you're infected. And that helped a lot in communicating the problems. So it's a great way to communicate. And it also helps you making more informed decisions, right? If you, especially in the case of situational awareness, let's say you have a world map where you map your data onto the different countries where things are happening. So if you are a company operating worldwide, you might have operations in Europe and in the US. So if you see that in Europe there's a lot going on at the moment, and in the US it's quiet, you probably don't want to add any more services or more burden onto the European people, but you can probably deploy these things in the US first. So it just gives you kind of a situational awareness, a more insight into what's happening, and you make better decisions through that. So now, why would you use visualization for insider threat? Well, the problem is, with insider threat data, or if you try to analyze these things, you will have way, way, way more data than doing your traditional security use cases. Because with insider threat, you're not monitoring exceptions. You're not monitoring just the things that go wrong. You're monitoring everything. It's not, there's no device out there that tells you, hey, this guy over there is the insider, he did this and that. No, people using their legitimate access, they have access to all the IP, for example, maybe patent filings. They have access to that. It's okay for them to access them. But as soon as they do something specific, they might take this patent filing and send it to the competitor. Well, now you have a case where something is not good anymore. But you need to monitor pretty much everything that happens. So huge amounts of data, and you need to handle them somehow. So again, you need tools to deal with that, and visualization is one of the approaches to take. Then you're going up the stack. Traditional security happens somewhere layer 3 and 4. You look at IDSs and firewalls, maybe proxies in some cases. Maybe you start looking at your operating system log files. But if you get into insider threat, you're starting to monitor transactions of applications. If you want to detect fraud, don't look in the network layer. You're not going to detect the fraud in there. You have to look in your financial applications, in your trading systems, whatever. Huge amounts of data again. And then a lot of times, you don't know these questions in advance. As I mentioned earlier, you might not even know what you're looking for. You have no idea. You're looking for some anomaly, right? And visualization often helps you find those. So how do you actually go about, or what's the process of getting data that you have into a graph? Well, it's pretty simple. On the left side here, you see a log file, anything, syslog, for example. And on the right side, you have the graphs you want. What you need to do is you need to parse your data, basically interpret the individual fields, right? Because when syslog comes in, when you look at that on your syslog server, it's basically just a string. I can't say I want to see everything that happened to this machine or from this machine to this machine. I need to take the event apart and say, oh, this is the source address and this is the destination address. There might be a username in there. So I need to parse it apart. You can think of it as taking the syslog and trying to put it into a database that has all these different fields. You need to figure out what is what and what goes in what column in the database. And one thing I want to mention here, don't reinvent, reuse. In computer science, that's a great thing to do, right? You use libraries. So go out there, use parsers that people have written already. They thought about the problem. They used it already. You can find some of those on this really ugly URL on secris.org. If you just go to the homepage, there's a section on parsers. So you can go there, contribute your own ones, and download the ones that are there. Now, on visualization, what you see a lot is the pie charts and bar charts, and some of the dashboards of the products you might have. Well, they're all nice, and they might have their purposes. Maybe not pie charts, but everything else. But there's something, there are more pseudographs out there to analyze security data. And what I use a lot is link graphs. So link graphs, again, are these things that have nodes and edges connecting them. And I will talk a little bit more about them in a second. The other thing are tree maps. And I find them really, really useful. On condensed space, you can visualize a lot of data. And I'm going to use them also a little later in the presentation. And then you have something called parallel coordinates. I'm not sure if you're familiar with those. Basically, what you do is you take the different fields of your event, the source address, the destination port, and each of them is one of these vertical lines that you see there. So on the left, you might have the source addresses, and then you have the destination address and destination port. and it's just going from 0 to whatever the maximum value is. And then an event is aligned through each of the parallel coordinates there, of the lines. I don't want to go into more detail on it. If you're interested, they're pretty interesting to use. There's a few open source tools out there that support them. One is ggobi. The other one is, I think, ParallelViz or something like that. You can ask me later if you want to know exactly what it is. So if you have seen link graphs before, especially in the kind of visualizing network data, security data, you always see these boring, like, source machine contacting destination machine. And usually the example they bring is worm detection, right? Well, anyone can detect a worm. You can hire a kindergarten student to look at the log files and say, hey, I see this a lot. There's something wrong. So let's go beyond just having source and destination nodes. What I like to add is a third node. And I usually use another shape for this. In this case, what I'm doing is I use a source address, an event name, and a destination address. So especially for IDS logs, this gets very interesting. Because suddenly you see things like this, where you have the blue circle, the blue square, which is a source machine. The green circle there is the event name, and then you have all the white ones are destination machines. Again, I'm using the example of a worm or a scanning activity here. It's kind of lame, but forgive me, I will have some better examples later. But again, what you see right away here is, well, there's a lot of activity that looks the same. And if you look at this, the circle over there, you can figure out what is it. You don't just know that this one machine contacted all these others. Because maybe it's a legitimate access, right? Maybe this machine really accessed all these others for a certain reason. But the other thing that's interesting here is not necessarily that huge fan of that circle of activity you see. I don't care about that. I care about the rest. What happens if I filter out all this and look at the rest of the data? That might be what I'm really interested in. So you can go beyond using the source address, name, and destination address. You can start to shake this stuff up completely. What you can do is you can say, well, let me take source IP, and I'm looking at the top right example there, source IP, destination port. Now suddenly I will see port scans very quickly because you will see the fan around the destination machine. You can shake it up even more. You can use source IP, source port, destination port, and you might see that different scanners behave differently, right? Like Nmap might randomize the source ports. I'm actually not even sure if it does. I think it does. There's some other scanners which don't. They use the same source port for every packet they send. So the point here is take something that's out there and be creative. Change it up. Now let's talk about tree maps for a second. You might look at this and say, whoa, what is this? Let's decompose this picture and analyze what this is. So by the way, on the top right, you see a URL that's a really good implementation of tree maps in Java. It runs pretty much in every machine if you have Java. And it's from basically the inventor of tree maps. So let's assume this whole rectangle that I have here is all my network traffic, let's say during the last day. Now, I partition it by the protocol, the transport protocol. I say, well, 20% is UDP, 80% is TCP. So I just partition this big space into 2080. Now, the next step is I add one more layer in this hierarchy. I'm not only using the protocol, as also the service. So what was running over this protocol? So now I just subpartition these individual pieces again, right? So in UDP, I have, let's say, almost, it was probably 85% DNS, and the rest is SNMP. And on the TCP side, I see there's HTTP, SSH, and FTP. But it's still out of those 80% that HTTP takes up about 45%, right? I will show you how you can use this with a little more complicated setups to analyze some other things. The interesting part is also the size and the color you're assigning to these boxes is completely configurable. Here it's kind of boring because the size is just the number of times I saw this. But you can also use the size as the sum of the bytes that were transferred, for example. The color could be something else as well. It could be something that's not even shown here. And it would just divide this one box up into more smaller pieces. Now, if you want to do actually visualization, you need data somewhere, right? You need to collect your data. You might have your syslogs. You might have other data. You need to have it somewhere. Now, I want to give you the 1 minute or 2 minute spiel on what Splunk is. Splunk is actually an open source tool that you can download. It's freely available on the web if you go to splunk.com. And Splunk is an IT search engine. What you can do with it is basically you deploy it on, I have it on my laptop here. You put it on the laptop, and you point it to a directory or a file, and it just indexes all your data. It's like a search engine. And then afterwards, I can search the data. And you can scale these up to thousands of machines that you can do federated searches. So basically, it takes log files, traditional security log files, but it also takes configuration files that it can index. It takes multi-line events. For example, if you have application servers, if you want to log, or if you want to index your Java exceptions from your web application servers, for example, a lot of traditional log management tools will have problems as soon as you get into multi-line messages and so on. So then what it does, it's a real-time index. So as soon as a new event comes in, it will be indexed, so you can search it right away. So that's a little different from all the other search engines that you might know, where indexing is updated not real-time normally. It's an ad hoc search. You can basically, like in Google or whatever it is, you type your search, and your data comes back. And I will show you in a second how that looks. It's a distributed and federated search, so you can have multiple instances, and from one, you can search all the others. It's transparent to you. It just gives you back the results. You can set up alerting, so you can set up every 10 minutes, I want to go through the data and see whether there is anything that looks like this, and if it's showing up more than 10 times, then I want to send an alert. Or you can set up reporting. Now in the latest version, there's a lot of like bar charts and all those stuff. That stuff is in there also. And one of the other interesting aspects, you can share knowledge. There's something called Splunk Base, splunkbase.com, where it's basically a portal where we try to share information about different events. So if you're in the product, or if you're looking at your syslog events, and you're like, what does this event mean? Every now and then I come across an event in my syslog, and I'm like, I have no clue what this thing is. So what you can do is you go to Splunk Base, and you can figure out, you can search for that event and see whether someone else actually contributed an entry there saying, look, this event is this, and these are the fields. Or you ask a question out there, and someone else can answer this. All right, so enough of that. I will show you how this looks live in a second. So we collect the data, and now we visualize it. And one of the tools, the ones that I wrote, is Afterglow. That's why I asked you before. So what Afterglow does, it's basically taking your data that you have. You have to apply a parser. I provide a few as examples, but I'm really not in the business of writing parsers. But what Afterglow takes is CSV input. You can always get your data into CSV somehow. You can write something that dumps your data into CSV. So that's what I'm taking. And then there's a configuration file, which basically says, well, if you see this type of data, make the nodes red. If it's like this, filter it out completely. So there's certain functionalities you can provide in a configuration file. And what it outputs is a description of this graph. Again, I'm not in the business of doing nice layouting and all that. There's tools out there that are really good at that. For example, GraphViz from AT&T, which basically takes a description of the graph saying, these are the nodes, these are the properties of the nodes, the color and the size and the shape, and these are the edges connecting them. And then they will visualize this, do the whole layouting and everything. So I stand in the middle, and I'm kind of mediating the two sides. So you have a CSV file, a few entries, right? Afterglow generates a graph description, which might look something like this. I'm sure you can't read this. But it's basically per node, it says these are the colors, and these are the edges. They connect these nodes, and so on. And then you pump this into GraphViz, and it generates a graph that looks like this. It's pretty simple. So why using Afterglow? Well, it helps you very quickly going from CSV files into a graph. And it helps you defining colors for nodes and edges. It helps you defining the sizes for the nodes. And the interesting thing is actually the property file that it provides basically takes Perl. It just interprets Perl. So from a security perspective, this is crazy what I'm doing, because it just executes the Perl. So you can do all kinds of injections. I don't care. It doesn't have to be secure, right? But it's very powerful because you just provide whatever code, and it just has to return the size of the node. So you can even read other files from within to calculate the size of a specific node. You can filter on different things. You can do, for example, fan-out filtering. So if you have a node that is connected to 3 other nodes, as this little example here, the fan-out of this one node is 3, if it's connected to 3 nodes. So you can say everything that's below 2, I don't even want to see. So you can kind of filter out noise that you're not interested in. And you can do clustering. You can say, well, everything in this A class is one node instead of every node of that A class. So you can do all kinds of interesting clusterings. And this, it's mainly for your reference. I don't want to step through these examples, but these are a couple of examples of how to configure Afterglow for different things using the size or changing the size of nodes and clustering and so on. So let me give you a little demo of how you can actually take data in Splunk and output it in Afterglow. So let's see. I hope this is going to work. So if you connect to Splunk, basically it's a daemon running on your system. It opens a localhost web server. You log into it, and what it presents you is this home page. It looks like a browser, a search engine, right? You have the search bar on top, and I just type in whatever, like IPFW. I'm interested in my firewall logs from my box here. So it's real-time indexing all the firewall logs right now. So I type my search string, and it will bring back all the events that it found. And if I click this, this might look familiar. So these are my firewall events here. So now I could go in and change my search and exclude things and include things. It's pretty interactive here. You can hover over the fields and control-click to exclude things. I don't want to really go in depth of how the product works, but let me show you. If I use a little more complex search here, I can pipe my result into a command called fields. You saw before I had the whole event. Now I want to take out the source address, the destination address, and the destination port. And I want to visualize that. So this is the command to use. What I'm doing is I pipe this into Afterglow, which is a command I wrote by myself. It's actually fairly simple. The whole product is very open. There's a lot of APIs where you can hook in and do things. So what happened in the background, my little processor built an HTML page which has an image inside, which is the graph, and it calculated an image map on top of that. What I can do now is I can open this and demo effect. But I think, oh man, I hate this. What it would give you back if it worked. Here we go. I don't know what happened. It gives you back a graph of that traffic. So you see, and there's some configuration file in the background that didn't show you that actually controls the colors for this, but you see it is 1099.0254 was connecting to a multicast address on 2313. You see all kinds of other activity. I can now click on these nodes. It takes me back into Splunk and it executes a search for only that node. So it's fairly interactive what you can do. What you can also do is, instead of using this in the web interface, I can even do that on the command line. It's bigger. So basically what you do is you are executing Splunk and you say search IPFW. And if I actually used the right syntax for this, I am not authenticated, so what I need to do is search IPFW admin change. So I had to authenticate against the server, otherwise I can't do a query. what it does, it just brings you back to the result just like before. And I can put that whole string in here again with the fields, let's say source address, destination address. I hope I was able to spell, yes. So here you see all the source and destination addresses. The blank lines in between are events where there was no source and destination address. What I can do now, you take this result, pipe it into awk, do some magic here. Tab. You basically want to change this format into some CSV. Oh, almost. I can't write awk today. Yeah, you get the idea. Not sure why this is not right. Yeah, let's leave it as an exercise. I think the field separator is wrong here, but yeah, this works more or less. So now you have it CSV, and you pump this into Afterglow, and you visualize it, and you can process it even more. You can do a grep on it, and whatever you want, right? I think you get the idea. All right, so let's go back to the presentation. It's funny, I have a screen over here that shows me the time. Now it doesn't. It says need to clear room for Deputy Prime Minister. So here for your reference, these are the commands again. You'll find them on the slide if you want to play with this. It actually has the right awk syntax also. So let's actually talk about insider threat now.
Sorry, can I just have a quick interruption?
Please.
I gotta explain the signage. Basically, I know Raffael, Mr. Marty is supposed to actually end at 6, and we just wanted to let you know that the Deputy Prime Minister is actually coming into the hotel, and we've got fresh instructions to clear the room 20 minutes earlier, 15 minutes earlier.
So I have to hurry up like really, really a lot?
Kinda, and out of our hands sort of thing, so.
All right, let's see what I can do. It's not my fault, it's good. Okay, I talked fast. Kernel former employees or contractor who. This is the definition I found on the cert.org website. Now, let's not do this. It's no fun. But I can explain it. And you know what an insider is, right? It's someone that does something that he's not really supposed to do. And usually the person is inside of the company, so he has legitimate access to those things. Insider threat, you can partition into 3 bigger kind of types. There's information leaks. Basically, anytime any important information belonging to the company is leaving it, right? Intellectual property, blueprints, source code. Source code is a good one. Sabotage is if someone destroys something. And this doesn't have to be like really necessarily physically smashing a computer. It can be that there's a logical bomb destroying data. There's all war stories that you probably know about cron jobs that delete things, whatnot. Fraud is anything dealing with misuse or abuse of privileges to, or you get it. You do trickery, you basically, you play normally on the application layer somewhere, usually has to do with money. There's all kinds of fraud, real estate fraud, tax fraud. There's discovered my roommate is a certified fraud examiner, and he has this handbook. It's like literally this thick, and it's all about types of fraud. I started looking at it, I'm like, this is great. This is a super manual for being malicious and committing some fraud. It's amazing. So it was interesting. There's some studies out there. The really good one is from CERT that I quoted here that basically talk about the types or the people that are behind this insider threat. And what is very interesting, a lot of times before they actually become active, they do some reconnaissance. So it's barely ever that an insider just goes and spam, and here's the fraud I commit, or here's my sabotage, whatever. They usually start looking around first and get a little more comfortable and want to know what they do. So based on that, what you can do is you can set up precursors. So things, detectors, they're called in some research paper I read. Basically things you want to look for that might indicate someone either already committing some or doing something he's not supposed to do, or possibly indicating he will be doing that. And now this I can use to define an insider detection process. So this is something I propose to do. There's no product out there that does this. You can go off and do this on your own. There will be a lot of questions you have. The first one is, you need to build this list of precursors. What is that list? Well, I don't know. I can give you examples. For example, if people start looking at Monster.com, job websites, Dice.com, whatever, are they really, like, why would they do this? Is this normal? Either they're looking for a new job themselves, or they're looking what's out in the industry, but a lot of times it's probably not normal. Maybe your HR department does them, and they post jobs on those sites, but probably not for everyone, right? You might see large emails going to public webmail accounts. Well, there might be documents someone is sending out. There's a ton of things you can look for. Printing, for example, look for printer file names if they have resume in them. Maybe someone is printing his resume. Well, it might also be the hiring manager printing out the resume of this guy he's going to interview. So there's always two sides, but they are potential precursors to someone doing something. Well, now, the second step is assign scores to these precursors, right? So someone just going to Monster.com, I give it a 1 on a scale from 1 to 10. But a salesperson accessing patent filings, not normal at all. I'm giving this a 10. So you play with the scores, you assign them, and then the next thing you do is you apply these precursors on log files or on the data you have. So I look for someone looking for password crackers in Google, right? Why does someone need a password cracker? So I'm going to put this user on a watch list, for example. So then what you do is all these people you put in a graph. This is not much data at all here. This is just maybe 24 events here. But what you start seeing is all the light nodes are the users, the green nodes are the precursors that triggered, and now you start seeing patterns. And I group them together with the red markers to show which ones are probably the same role in the company, right? Engineering versus sales versus finance. Well, the interesting thing is now, if you know what role they have in the company, you can superimpose that here and color the nodes by that. So suddenly you see that this one engineer, Greg, was accessing source code, which he probably should if he's an engineer, if he wants to do any work. But he also accessed patent filings and customer data. Engineers should hardly ever deal with patent filings. You should not read patents, maybe patent filings, but not public patent applications of other companies, because if you start reading them and you start doing something similar, they can claim you looked at their work and that falls under the patent, whatever. So there's something not really